So hi everyone. So we are going to solve today's Leetcode problem. Partition array for maximum sum. So it's a medium problem. Let's read the question. Given an integer array ARR, partition the array into contiguous subarrays of length at most k. Okay, at most k. After partitioning, each subarray has their values changed to become the maximum value of that subarray. Okay, return the largest sum of the given array after partitioning. Test cases are generated so that the answer fits in a 32-bit integer. So let's see. 1, 15, 7, 9, 2, 5, 10, k equal to 3, 84. ARR becomes 15, 15, 15, 9, 10, 10, 10. Okay, so let's understand the problem. Okay, so let's see. Now, what is the question? 1, 15, 7, 9, 2, 5, 10, 1, 15, 1, 15, 7, 9, 2, 5, 10. Okay, so he given k equal to 3, right? You can see k equal to 3. Now we can partition the subarray. Okay, continuously we can partition with at most k equal to 3. Means we can partition here one partition, or and second partition can be 2, third partition can be 3, right? Like this we can partition, or we can partition here at once, we can partition here, and we can like this. Okay, now so at every index we have three possibilities. That means we can partition either here, or we can partition here, or we can partition here. Right? There are three possibilities for every index. That means there are k possibilities. Okay, that's one thing. Now let's see. Now we need to return the largest sum of the given array. Okay, largest sum. But there is a condition here. After partitioning, each subarray has their values changed to become the maximum value of that subarray. Okay, so let's say if we partition like this. Okay, if we partition like this, then what will be the subarray now? The maximum, right? In this partition the maximum is 15, so it will become 15, 15, 15. In this subarray the maximum is 9, so 9. In this subarray the maximum is 10, so 10, 10, 10. So that's what the answer is here, right? You can see 15, 15, 15, 9, 10, 10, 10. So if we partition it like this, then we'll get this answer, and the sum whole will be what? Here you can see 84. So this is the maximum, right? Suppose if we partition it here, then what will be the result? 9. Here 2 will change it to 9. So this is the partition 10, 10. So this will be how much? 83, right? So we need to partition in such a way that the maximum sum, we get the maximum sum. So we have, you can see this is a DP problem, right? We have a number of possibilities here, and yeah, so let's solve this DP problem. So this is a medium question only. You can understand it better. The coming up with the solution might be tough, but understanding the solution is easy. So let's see what we can do here. So there are two things in this we need to keep in mind. The first thing is partition. How do we do the partition? You can see here at the first I said that we at every index we have k possibilities, right? So you can take the first index only, or you can take these two elements, or you can take these three elements. So k. So basically what we are doing, it's a for loop for I to k, right? For index idx to k we have these many possibilities, and we'll solve it here. Okay, that's the first thing. So the first thing is done. So we need a for loop in our function, in our DP, and we go to each and every possibilities. The second thing what you need to do is how to get the answer. What is the answer? The answer here is we need the sum here, right? For every partition. Suppose we took the first possibility as 3. Okay, so in the third we need to add it to the answer in the sense 15 15 15. So for this we need to keep track of Maxwell. So basically when you are going to that third this loop 1 comma 15 comma 7, so at every index we keep a max value. So max will be 1, max will be 15, and here also max will be 15. Okay, so 15 is the max value at the end, right, at the end of this for loop. And then we need to 15 into 3, right, the sum 15 plus 15 plus 15, 15 into 3, which will be 15 into j. If we keep it as j here, you know, right, here k means j equal to index to k, right? So this is the j value. J value will be here, it will go here, it will go here. So j minus initial index, that is idx plus 1, this will be 3 here. Okay, so when I write the code you will understand it clearly. So these are the two things only. So I'll write the code and you will understand it better. So let's see. So int solve. Okay, int solve. So what all we need? Int index. We need int index, and we need size of the array, the max element. Okay, int 10, and then we need vector int that arr. Okay, array, this array we need, and we need dp vector int and dp, right? Now if idx, no, before this we'll do it here on int n equal to arr dot size. Okay, now we did array size. Then what we need? Vector int dp n comma -1. Okay, so we are initializing a dp vector with n comma -1, and then return solve what? Index will be 0 at first. Next we need n, will pass n arr dp. Okay, we need k also here, right? So k n int k. Okay, now we have this solve function. Here first is the base case. If idx greater than or equal to n, return 0. Basically if index is greater than n, that means it goes out, will return 0 simply. That's the base case. Now if in a dp, if dp of index idx not equal to -1, return dp of idx. Simply we are returning the dp. Okay, that's the dp problem. Now what I told, we need one for loop for int j equal to index. Okay, int j equal to index, j less than what? J less than k, j plus plus. Now we are looping from index to k, right? As you can see here, for index to k, that means from 0 to 3, like that we are looping. Now this k, what happens if the index is the last element? If the index is last element and we add k, then it will go out of bounds, right? So the k can be, the j loop can go minimum of n comma k. Okay, so basically what we are saying, it cannot go out of bounds, the index. So at most it can go to the nth element. Okay, No, it's not k, it's k plus index, right? Why? You can see here I to k is 3 only, so we shouldn't look from any index to the 3 plus index, right? So idx plus k. Okay, I hope you understood. K plus index, and k plus index cannot be greater than n, right? So that's why we are keeping the max element as n. Now what? Now we need maximum value. We need to compute the maximum value, right? Int max val equal to 0 comma int answer equal to 0. Now what is the max val? Max val, so max val, right? So max val equal to maximum of max val comma array of j, right? So what, this loop will go from 0 to 3, then air of 0, air of 1, air of 2 will get the maximum value. So we'll get the maximum value, and what is the answer? Answer equal to max of answer comma the formula. What is the formula? Max val star j minus idx plus 1, right? So this is the answer. So max val star j minus idx plus 1 will give you that 15 into 3. 15 3s are 45 here, like that. Okay, now we'll add it to the answer, but there is one other thing we need to do. This maximum is incrementing, right? So what we are doing here, we are adding one thing, plus solve j plus 1, j plus 1 comma what, n comma k comma arr comma db. So what are we doing here? Where are we adding this solve j plus 1? So basically what we are doing here, suppose let's see. Okay, so we have 1 15 2 5 3, right? So if we take the first index, so in this index there are three possibilities. Okay, if we for the, if j equal to 2, then we'll take these two, right? 1 comma 15. After 15 the answer will be 15 into 2. Answer is equals to 15 into 2 30, plus what, after that we are again doing solve j plus 1. So j is here, j is at 15, then j becomes 3, so we'll go to here and then we'll solve here. So what we are doing, we are solving again here, and we are doing 2 comma 5, right? So if we take 2, the answer will be 2, so we'll do 2 plus, again we'll make j plus 1 here. So this is 5 comma 3, then 5 5, if we take these two, 5 5 10, so 10, like that. Okay, we are solving j plus 1, like that it goes. Okay, that's the dp here, that's the recursion part. I hope you understood. So you can see here answer equal to max of answer comma that that subarray, that partition sum max val into j minus idx plus 1 will give the answer of that partition, and we go on to solve the next partitions j plus 1 and comma k r of dp. So this will give the answer, and we'll store it, return dp of index. So at that point dp of index equal to answer, right? We'll run and see. Okay, shouldn't be int here. I don't know, let's see. Okay, return. So here, okay, we got the solution. Submit. Yeah, you can see here, right? So this is a DP problem. Once again, I'll just go through fastly. So we have this array 152. We have at most at most k possibilities for partitioning. So we can partition is 1, here 2, here 3. So we'll write a for loop from that current index to index plus k. Okay, index plus k, remember. So from 0 to 3 or 3 to 6, like that. Okay, next, for in that for loop we'll calculate the max value, and in answer we'll add that max value. Okay, answer equal to max value plus solve of j plus 1. Okay, here j plus 1, like that. So it's a simple problem only. I hope you understood. Thanks for watching.